Hello, everyone, and welcome to another opportunity to learn about data science. My name is Matt Hershey, and I'm really excited today that we have Julia Silge who will be joining us to tell us about tidy models and modeling and machine learning, all in the tidyverse. Julia, hello and welcome.
Thank you so much for having me.
I'm really excited to talk to you today because you have been both an inspiration to me in my own data science journey and learning, but then also so many of you watching have also asked, questions about modeling and machine learning, and this is going to be a great opportunity to really get into this. So, Julia, I'm curious. The our data science community oftentimes starts with this "about me" slide. And this is actually foreign to me, coming from the sort of hardcore biomedical sciences, which usually we have somebody to introduce us, so we don't have to introduce ourselves. But since this is our sort of community type event, I will ask you to introduce yourself. And why don't you tell us about yourself?
Sure, sure. So yeah, my name is Julia Silge, and my academic background is in physics and astronomy, and I had a little bit of a winding career path, in academia, teaching and doing research, and eventually left academia, and then had a couple of kind of random jobs, doing things like I worked for an ed tech startup. Actually spent a couple years as a stay-at-home mom, and about 5 years ago, I guess in the other order, but and about 5 years ago, I made a transition into data science, and I had a quantitative background, a background in coding, but I didn't really have really like modern data science, either coding skills or some of the like modern machine learning and modeling skills that are used now. And so I started learning as much as I could, kind of updating my coding skills to are used now, and made this career transition into data science. So my first job, where my title was data scientist, was at a non-profit consulting firm, or a consulting firm that did like statistics and data science consulting, which was a really great, like a great sort of first place to be able to do data science, to have a lot of impact, work on really great projects with really amazing coworkers. And then I was a data scientist at Stack Overflow for quite a while. And now, coming up on a year now, I work at our studio, and our studio, my title is technically software engineer, which is pretty interesting to kind of think about, like, whoa, is that what I am now? Is that what I do? But the answer is yes. That's what I do. I now like develop open source software for my day job. So it's kind of interesting to think about. Maybe when I was at Stack Overflow, my job was kind of 80%, 20% analyzing data, 20% building tools, like internal tools, internal R packages, developing open source software. And now I would say it's like flipped, where I spend 80% of my time building tools, writing open source software, and then maybe like 20% of my time actually analyzing data, usually for the purpose of either teaching or something internal at our studio.
So then, why R, and when did you fall in love with it?
So I would say, my computational background is like C and Fortran and stuff like that. And I like 5-ish years ago, when it was time to, hey, like like learn something that can get a job with now.
Yeah.
Not that people can't get jobs with C, but I started learning Python first, and then kind of got exposed. I didn't actually even know there was such a language as R. I'd never heard of it ever. And I was like, oh, what is this R thing? And I started learning R. I think I was exposed to it through the like one of the big MOOCs, like one of the big Coursera MOOCs, and I loved it. I think what made me click with R was that that the it is something that has a like a very functional approach to data analysis. And I am someone that really loves functional programming and does not really love object-oriented programming so much. And so, the very sort of Pythonic way, I was kind of like, all right, fine, I don't love this. And then the sort of, so I learned our tidyverse first. Like I learned our um, with dplyr, even with purr, like purr already existed when I started learning R. And so like learning R from this functional first, I mean, R has this kind of lispy background and history. So learning R with this functional flavor to it, I was like, oh, yes, perfect. I love it. This is exactly how I think about data analysis, how I think about dealing with data. And it's like just the right flavor for me. And also pretty soon after being exposed to R, I was exposed to the R community. And I was like a physics major as a very young woman, and then was in grad school in as an astrophysics. And when I had decided to go back into this technical field, I'm going to update my skills and go back into this work, I mentally really had geared myself up like, okay, I'm going to go back in there, it's going to be rough, but I'm going to do it. And engaging with the R community, my experience was totally the opposite. Even like I found this community that was fun and creative and welcoming and full of interesting people doing interesting things. And so it was kind of the combination of those two aspects of learning R that made me uh, love it, that made me realize I really like being part of this community, that made me realize that it's a good fit for how my brain works, how I think about data analysis.
So let's dig in that a little deeper because we have a pretty broad audience here. I'm curious, people have talked about a functional programming language versus an object-oriented programming language. If you just broke down and maybe a simple analogy, like how do you think about the difference between these two like general concepts?
Yeah. So I'm not someone who has formal computer science training. So I apologize if what I'm about to say is a little bit wrong, but I'll give it a go. So like functional programming is focused on functions where you put inputs into functions and you only focus on what comes out of them. You don't have what are called side effects. So things that might happen that are side effects that you might be familiar with is like, printing something to the screen or changing something about the state of what's if you think about your R environment, for example, like changing something in your R environment that's not the output of the function that you created. So functional programming, you just put in inputs and you just have outputs that are come out. Object-oriented programming instead views the like an object as important, and then you have usually methods that are like getters and setters where you go in and out and you can change things that are in the object. And so you're less concerned with things like side effects and changing state. Like you're more okay with it, with like changing things, it's changing state.
I ask partially my curiosity of how you're thinking about it, also partially because I, like you, don't have formal training in computer science. But I think that more and more often, people are getting exposed to what we at Duke and in our community are calling computational thinking, which is really approaches to thinking about computation. It's a little bit meta, but approaches to how you're going to solve a problem. And it was really interesting that you said that you find one type of programming approach like works for your brain, I think you said. And so it's interesting because of course, there are the flame wars on R versus Python, or whatever the best tool is, and so on. And my approach is, an analogy that I recently sort of gave in one of my sort of teaching videos, is that it doesn't really matter what tool you use, because you can think of yourself as a chef. And if you think of yourself as a chef, then it doesn't matter, I said on the fly, if you grill or you sous vide. At the end of the day, do you create the meal at the end? And the tools that you use are going to be less important than, especially in data science, there's usually a goal, an outcome, a task, something that you want to do. And I think that, finding a language that works for you and resonates with your brain and your wiring and so on is going to be most important.
Yeah, absolutely. And there's like really such well-developed, mature tooling for doing, data analytics, data science in both Python and R worlds. Like you can't really go wrong.
Yeah. So then I'm really wanting to know, because many in our community are self-taught. And in fact, part of my effort here is to bring resources and ideas to this growing community to continue to learn, which is why we wanted to really sort of get into some of the tidy models and so on. But I want to dig a little bit deeper, because you said that you decided to dive in and you took a MOOC, but what did the early days of you deciding, okay, this is something that I want to invest in and something I feel like I need to know, and I'm eager and curious about it. What did those early days look like?
Um, so let's see, what did they look like? I so I came from this background in astrophysics, and what I actually did, like say during my PhD was and postdoc, and during those days when I was involved in research, was I would go and take data for maybe like a week at a time, once a quarter or something. But what I did the rest of the time was analyze, like write code to analyze data, write about it, make plots, communicate about what it meant. And if I fast forward sort of a couple decades later, and I started to see people um, from either like my cohort, like people around my age who were making career changes, or either even at that time, like people who were younger than me, like making this career change into this thing called data science. I would talk to them and be like, "So what is it that you do for your job?" And they'd say like, well, I write code to analyze data, and I make plots, and I write about what it means, and I communicate, like communicate with people in the business. I'd be like, wait a minute, that was my favorite part. That's what I like doing about, when I was doing research. Like what I liked about it. There's a job for that now. Perfect. That's what I want to do. So kind of realizing that there was kind of a profession forming around did this kind of skill set, was a big motivator for me to look into more deeply what specifically, what kind of concrete skills do people need to have to like move into that from where I was. At the time, I already had sort of on paper, like the right kind of degree to move into that kind of skill, but like what did I need to make a transition in? And like what areas in my own sort of knowledge need to be filled in to be able to move over. So though I would say those were the things that sort of initially uh piqued my interest and made me want to look in, was kind of this sort of forming around this set of skills as a professional identity. I would say before that, people who were moving into industry, physics or astrophysics, were going, I mean, they were doing very similar things, but they were maybe going into finance and, building models for trading. Maybe they were going more to a more engineering role, maybe moving into software engineering. But I had not yet and those held. I found myself less drawn to how those roles were described or what people said they did all day. And so it was when this description of this set of tasks as a job started happening. I was like, wait, yes, that is what I want to do. That I really became interested.
I see. I personally feel lucky that the tools that are available today have helped me sort of quickly get to where I am, as opposed to previously, 5 years ago, 10 years ago, the tools that are available were just more rudimentary, and so it's quite, I guess, lucky that the tools are available. So one of the things that I want to touch about is some of the tools that you are starting to develop and build. And so we'll talk a little bit about tidymodels, but why don't you give us just a brief introduction to tidymodels and the motivation, what it is and the motivation for it and so on.
Yeah, so tidymodels is a framework in R for modeling and machine learning. So it is a set of R packages. So if you've ever used the tidyverse for data visualization, reshaping, manipulation, you've probably typed library tidyverse, and then you've had functions for summarizing, for making plots. So when you type library tidymodels, you load a set of packages that are each of which are address a certain part of the modeling process. So one of the packages, for example, has functions for data resampling, like breaking apart data sets into resamples for to get better, more reliable results. And one of that one is called RSample. One of the packages is for model evaluation, for being able to say, hey, I'm at the end, I have a fitted model and I want to be able to see how it's doing. And that model is called yardstick. So it's a set of packages. It's broken up into different pieces to improve our ability to maintain the packages in a more fluent and more responsible way, rather than having like one ginormous meta package. Some of the goals of tidymodels are to provide like a unified, cohesive way for us as human beings to interact with models in R. The modeling ecosystem in R is a little bit of a wild west. If you've worked with a little bit of R and a little bit of Python, you may have noticed that in Python, it's like, there is one way to do something, and it is the Pythonic way. And like there's one way. And in R, it's like, look, there's 5 packages that do the same thing. It's like there's literally like 5 ways to do everything. And I think there are pros and cons to both approaches. One of the cons of having so many like ways to do everything is that when you want to do one kind of task, like fit a model to data, but there are actually, literally, I'm not joking, a dozen interfaces to that same kind of task, it just becomes overwhelming, exhausting, difficult to build, for any individual analyst to be able to learn that, to be able to build good work, analysis scripts, to be able to do that. So one of the goals is to provide a unified API to models in R. So the analogy here would be scikit-learn in Python. If you've ever used scikit-learn and you're like, oh, I go to one place for all the models. So the analogy here for tidymodels will be that. If you've ever used, it's not the first time this has been, someone has tried to do this in R. If you've used Caret in R, that was an earlier iteration at the same task by Max Kuhn, who is my boss at our studio. So I work for and with Max on tidymodels. So this is like a new, more modern take on sort of that same sort of goal of a unified API for models. If you MLR or MLR3, you notice that the MLR people also have gone through multiple iterations. It's another approach in R for, hey, there's all these models out there. I want to have one approach to it. And so other goals that the tidymodels framework has is to use tidyverse data structures and principles. So some of these things mean reusable data structures that you don't have to keep like reshaping awkwardly your data. You use tidy data, you know it, you love it, you know how to make plots with it, and you can do that with your model data as well. You know how to use ggplot2 and dplyr. If you like those, then you might look into using tidymodels. The last goal that I want to talk about is to really think about carefully what is good statistical practice when it comes to modeling machine learning, and to build that in to the defaults, the design of how you use the functions, and sort of a little bit of like the guardrails that are there in the function. So I'd kind of summarize those three things as what tidymodels is, like a unified interface to models, using tidyverse principles, data structures, and syntax, and with the goal of good statistical practice.
How has the uptake been so far? I'm sure one of your key roles at Stack Overflow was looking at use of Stack Overflow and counting things sort of within how people are querying and sort of what those trends look like. So I assume that you and Max and others have looked deeply at how the tidymodels is going. So give us a sense so far of the uptake or the use so far.
Yeah, we've seen a really big change this year. I would say at the beginning of this year, tidymodels had just barely gotten to the point where it was mature enough to be used in real projects, like your real world work. It was in a bit of a uh, uh, exploratory kind of approach before, say, this past January. And maybe as of our studio conf this past year into the early spring, it really kind of crossed the barrier into being something that was ready to be used for production work, for your real analysis with your real data at your job, And over the course of this year, we have seen a really enormous increase in use. I think that that has come, when you have something like that happen, it definitely comes along with some growing pains where you all of a sudden discover the edge cases that maybe you thought weren't so important ahead of time, and you're like, oh gosh, no, we got to fix that. That's something that we really need to solve. So that's been exciting to see, and also interesting to walk through. If you want to talk about absolute numbers, a very mature framework like Carrot probably still has more an absolute number of users, but it will, as we see things, shift and change over, maybe the coming year or something, it'll be interesting to watch that. If people come and talk to us about Carrot versus tidymodels, we usually say, there's no reason to redo a project that's in Carrot right now into tidymodels. Like there's no reason to rewrite it. If you're going to start a new project, definitely start it in tidymodels, because Carrot is going to continue to be maintained, but there's no new development in Carrot, like no new features or anything. New development is happening in tidymodels. So if if you have some reason to rewrite something, I would rewrite it in tidymodels. If you're starting a new project, I would do it in tidymodels, but there's no reason to, throw away Carrot code or anything like that.
But the thing that I wanted to ask you though was about the this distinction and how you make this distinction between modeling and machine learning, and why you still make this distinction.
So I tend to use those words in not super different ways. I tend to use the words machine learning and modeling in fair, mostly interchangeable ways, like in interchangeable situations. When people say machine learning, they often will be talking about building a model with the purpose of prediction, like where their main goal is they want accurate predictions. And if someone is talking about modeling, they may be talking about other purposes. So they may be talking about building a model for maybe the principle of like inference, like understanding not just like I want as accurate a prediction as possible, but maybe I want to understand why, like what are the relationships between some inputs that I have and some outputs that I have, or they maybe want to just build a descriptive model where they're describing the relationships that they have in their data. They're not really interested in like a why kind of question, but just like what are the relationships like. So I think that in general use, when people say modeling, they might be more in the descriptive, inferential kind of regime. And when people say machine learning, they might be leaning towards more the prediction kind of regime. But the word, I don't think that those words mean drastically different things. And I often will, maybe use both to kind of make a big tent to say I'm kind of talking about all of them because we use really similar techniques for all of it. I think that often, if our goal is building a descriptive or an inferential model, it can be important still to measure things about the predictive capacity of our model, because, and that's often something that goes underreported or undermeasured when it comes to, say, inferential models. But they can really help us understand, like, is this model actually good for anything? And so if we're going to talk about principal component analysis in this walkthrough, principal component analysis, if you talk about maybe like the whole process of modeling, it can be used, say, in a descriptive sense to say, here are here are how these variables are related to each other. Here's where the most these variables are most different from each other, and like where we see the different various variances. We also can use it in a predictive sense. We might use it as a way to do dimensionality reduction, and then be able to build features for prediction that work better than the variables that we had to start with. So you can use principal component analysis in a couple of different contexts within this sort of modeling and machine learning umbrella. So I would say that it is good kind of in the descriptive sense, and then it's good in the feature engineering part of the modeling process.
I want to ask you something that I think comes up quite often. And so you are giving, we'll say, people like me a superpower, right? That candidly, I have no business wielding, right? I'm not qualified. I don't have the training, or so people like me and perhaps starting out might feel. So how do you then find the balance between giving people tools to do things that they could have never done before, but at the same time, those tools might then lead them down a wrong path because they have such capable powers? Candidly, like a principal component analysis. I mean, this is a very sophisticated dimensionality reduction algorithm that Akshay did on a Penguins data set. So how do you think about balancing this this sort of power and responsibility.
Yeah, it's a great point. So I think so I think for a good first thing to think about is like as a tool builder or as like someone who deals with data is to really wrestle with like where do you stand and or what is your opinion on like making tools accessible,
Yeah.
making tools like what are we going to do in terms of like communication, what are you going to do in terms of like in terms of what do you think quote regular people should be allowed to do, um and like basically what is your opinion in terms of like are there certain things that only like a licensed statistician should be allowed to do? I first heard I think Hadley say this in a talk, and I can't remember if he was quoting someone else, but like what he said is that like we have a lot of evidence that like abstinence only education does not work, and it I really think it does not work when it comes to stats and machine learning. Like people have access to data in their jobs and they know about this stuff that's out there, you know, like they know about random forest, they know that this stuff is out there and they're not going to not use it because it's like, oh, I heard it's hard to apply well, or I heard that you can make mistakes, or I heard, or like, oh no, the uptight statistician told me I'm not doing it right, you know, like people are not going to not do it they because someone told them they're not doing it perfectly.
You're
They're
still
going to
talking
do it
about
anyway.
stats.
I mean, I think the analogy is perfect. I think it's a literally
Yeah.
perfect analogy. Um, and because and so what do? We do like harm reduction. We do like we do and what does that mean when in terms of like tool building? What does it mean in terms of education, in terms of documentation building? It means you know that all kinds of people with all kinds of backgrounds and education levels are going to be attempting to use these kinds of tools, and so you build you know like when we write our books, when we write our documentation, when we build the tooling that we do it with the mindset that like people from a wide variety of backgrounds are going to be using them. And so we have goals to encourage good statistical practice by how we set things up, but both in terms of how easy is it to get on the right path with what we're doing, and then how do we like what do we show when we demonstrate, what are in examples, and then how do we teach, how do we demonstrate, what are in our materials and books. So I mean I think it's a little bit of a you know, a philosophical question, and I mean probably you know people have different opinions on this, right? But I think as a um you know, if you're say you might have a different opinion if you're like in an organization and you're like, okay, who do we want building our models, having access to our data? We want to make that the responsibility of the people we know have the most appropriate background. As someone who's a tool builder, I think I want to acknowledge the reality that a lot of different kind of people are going to be doing it and build tools with that in mind.
Sure. No, that's great. Akshay asks a question. He says, "Is there a plan to integrate tidy models with deep learning tools like Keras and Torch?" Of course, one of the more
Yeah.
exciting developments was the integration of a native library for Torch into the sort of R ecosystem. So, what is maybe you could sort of tip the cards and tell us what some of the future looks like.
Yeah, so we already have an integration with Keras. So you can use tidymodels with Keras. So for example, you can use it for like like a dense network. I mean, we don't have support for every kind of network architecture, but we do have integration with Keras already. We are pretty excited about Torch because Torch doesn't involve going through Reticulate and Python.
Right.
Like it involves just going just like a native for our kind of situation. And so we're starting with the same stuff that we started with for Keras, which is like a dense perceptron, like starting with those sort of simpler network architectures that you can get started with, and and then we'll go from there and see what we can build. So there's already some there's already neural networks in tidymodels, and right now they are either some of those ones that are written in R or the Keras ones, and then we're actively working on Torch right now.
Excellent. So then maybe because we're a little late on time, I'll just take an opportunity to ask you one final question. And I'm just curious, what excites you about sort of looking into the future, whether it's something, in the R community or ecosystem, or, within the modeling or machine learning landscape? Like, what are you really excited about right now?
So I'm somebody who really does care about and get excited about like how people work in like the real world, like their everyday, getting their real work done kind of situation. And so one of the things that I've been working on some with like a set of user interviews of actually mostly our customers, our pro customers, and some like people who use our open source products as well, our like open source software as well, is this issue of like model management, model like kind of what people call like model ops or ML ops. So like you train a model, and then what do you do with it next? Like once you've got it trained, like what happens at this point? Probably you have it deployed somewhere, and then it's like then what? Then what? What like the analogy that I think about it, it's like someone giving you a puppy as a gift, where you're like, oh yay, and then you're like, you're like, a puppy, have a puppy. And like now we have to like start the process of like taking care of it, and doing all the sort of like the kind of annoying stuff to take care of it. Working on like I am someone who actually cares about a lot of that nitty gritty, and getting those details hammered out and helpful, and um, uh, I don't know if right is the a good word to use, but good, fluent. And so figuring out how, like, what are the right tools for those kinds of jobs? What do we have already that fills those needs? Are there new things that need to be built to fill those needs? So that's something that I'm really excited about right now.
Excellent. Well, I just then want to thank you. That is sort of, I think, exciting for a lot of us. But I really want to let you know I appreciate your time, coming all this way, but taking taking all of the time out of your busy schedule for our community here. So thank you. And just to let other people know, if there's elements of this that you think somebody would like that hasn't seen this is going to be on YouTube in like 2 minutes. So this will be sort of live, and we'll share the links and all of this. But Julia, thank you. I hope that we can connect in person sometime.
Thank you so much for having me.
All right. Bye-bye.